All right. So guys, not yesterday, Monday, we talked about the shortcut, right? The techniques for finding derivatives. The shortcut I'm referring to obviously was the power rule, and it's awesome, and we love using it, and you will keep using it. And today we're going to continue to use it. Need a little more guidance on that. We're going to keep using it today. What we're going to do is we're going to learn some new techniques. So all of these techniques, so the derivative can always be taken using the definition. I mean, any function, even if it looks really super hard and crazy, it can be taken using the definition. It's just that a lot of times using that definition is really hard to do. So these techniques we're finding are going to help us tremendously because right now, all we know is the power rule. We know how to deal with a constant or a coefficient, but it would be great if I could have rules that help me take the derivatives of really just any kind of function I come up with. So for most functions, we do have this. So we're going to learn a few more today. So this is 1.6. And this is the product and quotient rule. We'll call them rule. I guess it's rules because it's two. Product and quotient rules. Okay, so I'm going to give you an example of a function that has a product in it. And because of that product, we can't just take the derivative like we know how to so far. Okay, so I've got the function f of x equals x minus 2 times x plus 3. Now, notice and recognize that this is the product of two terms, right? You could call these two different functions of x because they're each a term with x in them. Now, before we get started with this, I do realize, and you probably realize too, that I could just FOIL these out and then take the derivative. And then I wouldn't have this function times function situation. Absolutely I can. Absolutely I would. But because we have such a limited knowledge of derivative techniques right now, I can't make these products much harder than they are right now because we just don't know enough about other types of functions. So, just bear with me. Pretend this is the product of two things that are just really crazy and we don't know how to deal with them. I promise once we get into some more difficult functions, the product rule will be necessary at a point. It's just we have to learn it now so we can use it then. So yes, pretend that FOIL doesn't exist and this is a product of these two things and you want to take the derivative. So here's what we cannot do. When you're taking the derivative of a product, so in this case it's two binomials, it could be it could be so many things. It's just we can't deal with a lot of those things yet. It could be two trinomials. Maybe you don't want to FOIL those, right? So anyway, I have a product. What I can't do is I can't take the derivative of this and the derivative of this separately and multiply them together. So remember when we had two terms added together, I had like 3x plus 5x squared. And I said, we could take the derivative separately and just leave the plus there. Absolutely, plus and minus, you can do that all day long. It does not work on multiplication. So I can't just take the derivative of this, which would be 1, and the derivative of this, which would also be 1, and just multiply it together and say the answer is 1. So please do not try to do that. I will show you a better way. So every time you have a product, So your function is a product. We're going to look at a lot of different cases, and I'm going to help you know when to use the product rule and when you don't need to. But this one we do, because remember, we don't know what FOIL is and we can't do that. You're going to take your product and you're going to label it as two separate functions. So usually when we're doing product rule, we use U and V. So basically break your product up into two pieces. I'm going to call this one U and I'm going to call this one V. So really you can think of this as, yes, this is a function f of x, but I'm thinking about it as a product of the function U times the function V. Why can I call each of these a function of x? Because they have an x in them. Any term with an x in it, we can call that a function of x. So I have function U, function V. Here's how I take the derivative of U times V. All right, so I'm going to write it in U and V terms, and then we'll actually do the problem. What you do is you take the function U and you multiply it by the derivative of the function V. And then you add that to taking the function V and multiplying it by the derivative of the function U. So basically, and it gets really easy to use as you keep using it. We've got U and V. We've got the original functions U and V. So this is original U, this is original V. And then we're going to take the derivative of each of those. And then we'll have the derivative of U and the derivative of V. So you have four things happening here. And notice you just pair them up in an alternating fashion. So here we wanted original U times derivative V. Here we have original V times derivative U. And you guys, this is the way we do derivatives of products. So let's look at our problem. Okay, so original U, so that's going to be this x minus 2, so the whole thing. So I do x minus 2. Now I need the derivative of V. So you guys, I would take this over to the side. Well, you actually might even start with writing V. So V is x plus 3. The derivative of V, using what we knew what we did last time, you could do it power rule using the x to the first. But remember what happened when we just had an x? We took the derivative and it just became 1. So the derivative of V, so you take the derivative of x and you get 1. That plus 3, it's not a coefficient because it's not touching an x, right? It's just a constant. So when I take the derivative of that, it just goes away. So this is just 1, you guys. So I have original U, that's right here, times the derivative of V, I just found that to be 1, plus original V, so this is original V, x plus 3, times the derivative of U. So if we take U over to the side, you guys, the derivative of U is also just going to be 1, because notice we just have the x and then the constant. So we get this. So then you just add. If this was something other than a 1, you would definitely have to distribute that. It is a 1, so I know what's going to happen here. I'm going to get x minus 2 plus x plus 3. Let's put our x terms and our constants together. So x plus x is 2x. I have negative 2 and then plus 3, so that's going to be plus 1. So you guys, I think this is the derivative of this. So can you see how I couldn't just take the derivative of each of them separately and multiply together. That is not what I got when I tried to do that. So we have to use this. This is what's important to us today. Now, do you think it matters if I label this one U and this one V, or if I label this one V and this one U? It absolutely doesn't matter. I like to stay consistent. Whatever I come to first, I call U, and the second thing I call V. But if you got those switched around, it would be fine because notice you pair it in both different ways and it's a plus in between. So either way you do that, it's going to be fine. But again, consistency, I go that way. All right, let's do another one. So again, I mean, once we learn harder functions, the product rule is going to be a lot more necessary than it looks here. Because again, I would have absolutely just FOILed that out. Then I wouldn't have that. I would just have a bunch of terms added together, right? Or subtracted, and I know how to deal with that. But I promise that will make more sense. It'll get harder and better. Okay, so here's something I want to make sure you recognize. All right, so we've done this before, something like this. You have to, now that you know, you have to look for these products and use the product rule when it's a product. You also need to make sure you know what's not a product. So you might look at this now that you know the product rule and say, ah, that's a product. I got to use the product rule because this is 5 times x to the 4th, which technically, yes, it is a product. But the big key in the product rule and when we have to use it, it has to be a product where both factors have the x in them. So they are both functions of x. If you take x to the 4th is definitely a function of x. But 5 is just a 5. You guys, if you have just a number times an x term, I know how to deal with this, right? This is just a coefficient. And it comes down with me, and then I do the power rule. So just be really careful. When do I need it? When do I not need it? Let's see. So as a review, since I have it on the board, we might as well take the derivative of this just to remember what it is. So remember when you're using the power rule and you have a coefficient, you bring the coefficient down and then use the power rule on x to the 4th. So that power of 4 comes down in front. The power on x becomes a 3 and you get 20x cubed. So no product rule necessary here. Let's see, what about, I'm trying to think of one that you know enough to do that actually makes the product rule necessary. So if that doesn't make sense, that's okay. No, we can't do that one. I keep thinking of good ones and I realize we don't have enough information. After next class, we'll be able to do tons of these things. So let's look at, guys, it's just going to be another one we could FOIL. Oh, I know what I could do. So guys, this will be another one that you could have FOILed, but maybe it gives us a little more complication. So let's say I've got f of x equals x squared plus 4x times x cubed minus 3x squared. All right, we can do this one because I know how to take the derivative of each of those terms. And notice they are a product. It's this factor has x's in it, as does this factor. So I know I have to use the product rule. Let's say that this function is u and this is v. And again, we don't know what FOIL, what is that? I'll just have to use the product rule. Okay, so let's go over to the side. Over to the side, let's write out u by itself. So if this is u, x squared plus 4x, let's find the derivative of u. It's always good when you're doing the product rule to find everything you need first and then go ahead and put it together. So the derivative of u, remember this is just power rule. This is going to become 2x to the first plus 4. You guys remember if it's just an x, with a coefficient, the coefficient's what comes down because this turns into x to the 0. Okay, so I have u and I have the derivative of u. And you guys, I'm going to start saying, because the derivative of is something we have to say a lot. Instead of saying the derivative of u, I'm going to start saying du. Or instead of the derivative of v, I'm going to start saying dv. But that just means derivative. I don't want to throw you off and think I'm talking about something new. So here's u and here's du. Let's write v down. So v is x cubed minus 3x squared. And dv, well, using the power rule, I'm going to get 3x squared minus 6x. So we have all 4 of our terms. So notice this one's just going to be more complicated because our derivatives didn't just turn into 1 like on the first one. Okay, so the derivative of this whole product, let's write out with the u's and v's. It's going to be u dv plus v du. If you don't want to memorize something like that, you've already got these 4 things here. Just pair them up, uv, and you'll get there. Okay, so let's write in what we have. Make sure you use parentheses because notice all of these have more than one term. So original u is x squared plus 4x times derivative of v, 3x squared minus 6x plus, I'm going to run out of room. Original v, x cubed minus 3x squared times derivative of u, guys, 2x plus 4. 2x plus 4, that is what that says. It is du. Okay, so from here, now on the last one, we had a bunch of 1s sitting here, right? So it was easy to simplify. This is a lot, right? You guys, this is like a whole nother FOIL, 2 of them in the problem. And it can be hard to know where to go from here, or how far do we have to simplify our answer is a good question. And that is a good question. We're going to take this one all the way out, like all the way. We're going to FOIL this, we're going to FOIL that, we're going to combine any like terms that exist, and we're going to get it to the most simplified form. I will tell you, while I do not have a lot of control over the way that MATLAB likes things, if we were doing a paper test, you know, like pretend it's 2019, right? And we're doing a paper test. I would actually want this line to be your last line. Reason being, this line is where I can see the product rule, right? I can see the u and the dv and the v and the du. I like being able to see this clearly. That's what I'm testing you on, right? The rest is basically just your algebra knowledge. But again, I don't have control over what MATLAB wants, and I haven't really, well, I haven't tried it on the product rule question. So we're gonna work this all out. I will let you know as you guys work product rule questions. So when I put 11.6 on later today, as you guys work those, you can also, you know, give me some feedback on how far it wants you to take this, because sometimes it's pretty far. You guys, sometimes there's a lot going on here. So right now though, we'll go ahead and FOIL it all out. Why not? Algebra practice. All right, x squared times 3x squared is 3x to the 4th. X squared times negative 6x is negative 6x cubed. 4x times 3x squared is plus 12x cubed. 4x times minus 6x is minus 24x squared. So it's not horrible, just a normal FOIL problem, right? Plus, now we have this FOIL. Remember, this is 2x plus 4. I know it's hard to see. But x cubed times 2x is 2x to the 4th. X cubed times 4 is 4x cubed. Negative 3x squared times 2x is negative 6x cubed. And then negative 3x squared times 4 is negative 12x squared. All right, so not the worst thing we've ever done, right? Okay, let's combine like terms. I have 3x to the 4th, and I have plus 2x to the 4th. So I'm going to get 5x to the 4th. Let's count our x cubes. So we have minus 6 plus 12. So minus 6 plus 12, we're at 6. Plus 4, that makes 10. Minus 6, we're back down to 4. Yes, we were at 10 minus, yeah, we have 4 of them, I think. Okay, so plus 4x cubed, and then we have x squared, and that's it. So we're almost done. Minus 24x squared, and we also have minus 12x squared. So it's minus 36x squared. So guys, in your work, if you do have to continue and do foiling and stuff like that, you really can't go any further than this. This is as simplified as this gets. But again, I would love it if it lets it leave it in some form like this. But again, I just don't know that it could, you know, be in a computer program. We'll just see what it does, and we'll do that. We'll do whatever it wants us to do. Okay, so that was a little more complicated, right? Because these numbers in here were more complicated. So that was a good use of the power rule. Well, still an unnecessary use of the power rule, but it was good because it took us a while and we got some good practice on it. But now let's get to the other rule of the day. So let's talk quotient rule. So what's nice about the quotient rule is I can actually give you examples where you absolutely have to use the quotient rule. So we're not going to have that failing like we just had, like, oh, we just could have done that easier another way. This all there is when it comes to a quotient. So I'm going to give you an example of a function that is a quotient of two other functions of x. I'm also going to give you an example of one that is not, just like I kind of did with that first one, just to make sure that you don't use it when you don't need to. All right, so let's just do really simple. I've got f of x equals x plus 5 over x minus 4. So I look at the problem. I can see it's a quotient, so my first thought is definitely quotient rule, right? As long as there is an x on the top and an x on the bottom, then yes, the top is a function of x and the bottom is also a function of x. I cannot take the derivative up here, take their derivative down here, and just put them over each other. We would end up with a 1 here, and that is not what the answer is going to be at all. So again, please don't do that. That only works with plus and minus. Multiply and divide, we have our special methods, right? So definitely, and we are going to do this one, but when I see it, I say, yes, this is a quotient rule problem. What about this one? So I see this and I'm like, hey, it's a quotient. But while it is a quotient, is there an x on the top? Is the top a function of x or is it just a number? Well, it's just a number, guys. So you have to be able to tell the difference between something like this and something like this. Yes, quotient rule all day long. This, I would just rewrite this, right? And use the power rule. I would call this 3x to the negative 5th. And then I would take the derivative with the power rule. So basically the difference between a quotient and just something with a coefficient. So we're being careful there. So let's get back to our problem that is a quotient rule problem. Okay, so we're going to use u and v again. This time it's actually very important which one is u and which one is v. So in the quotient rule, u is the one on top. V will be always the one on the bottom. So those are, you don't get a choice. U's on top, V's on bottom. All right, so here's what it looks like. So when you take the derivative of a quotient of two functions, this is what you end up getting. You actually get v du minus u dv over v squared. So it's not actually as horrible as it looks. I know it is a quotient in itself, but it's something you will, again, get used to. Now, I want to be very clear about something in this. Remember the product rule? Let's recall. The top of this looks a lot like the product rule. Remember the product rule, though, was u dv plus v du. Now, here's the thing about the product rule. It doesn't matter which of these terms comes first or second because there's a plus in between. This is just the way we always write it. We always do u dv and then v du. Notice the difference in the quotient rule. You start with original v. So these two terms are these two terms. They're the same terms, but notice which one's first. It's the v du that's first, and then the u dv is second. And you might think, well, does it really matter? Absolutely. This is a minus in between, right? You guys, because it's subtraction, it very much matters which one's first. So that, if anything, is what's going to get you here. Now, on the bottom, the v squared, don't let that throw you. It's not some weird notation for something different. It just means you take your v function, whatever it is, and you square it. So what I would do every time you do the quotient rule is take your functions over to this side. We're going to find du and dv, and we're also going to go ahead and find v squared. Okay, so u is the x plus 5. I don't know why I put that in parentheses, but there it is. Du, guys, remember this is just plus. So you can find the derivative of x, which is 1. The derivative of 5 is 0. So du is just 1. That's going to be nice for us. So v is the x minus 4. So dv is also just 1 because it just comes from this x term. V squared, you guys, that is just x minus 4 squared. So it literally is whatever v is squared. Just make sure you're squaring the entire thing when you square v. Okay, so these are the 5 puzzle pieces, right? We just have to put them together. Okay, so on top, start with original v. So you have x minus 4 times du, which luckily for us, it's just 1, minus, don't forget that's a minus, original u, which is x plus 5, times dv, which is just 1 also. And then on the bottom, you have x minus 4 squared. So that's not too bad, right? We just have to simplify a little bit. So let's see, let's do that. You guys note that this is just x minus 4 and then x plus 5, because you distribute the 1, they stay the same. So on top, we have x minus 4. Now, you do want to be very careful because this is a minus, right? Minus x minus 5. So I have x minus 4 minus x minus 5 over the x minus 4 squared. X minus x. Oh, you guys, I gotta plug in my computer real fast. So that x minus x in the top, the x's are actually going to go away on top, and that's okay. You're going to notice that that happens sometimes, especially in a case like this where both the top and bottom have the same degree. But yeah, it's fine. X minus x, those x's are gone. What we're left on top with is minus 4 minus 5, so just negative 9. On the bottom, this is another one of those uncertainties, because I have not had the experience or pleasure of doing actual homework in MATLAB as a student. A lot of times, honestly, usually when we use the quotient rule, we leave the bottom like this. We don't actually FOIL that out. So this is how, like, again, if we were pen and paper testing, you could just leave it like this as x minus 4 squared. But again, I don't know what MATLAB wants. And as we work on the first few questions of 11.6, guys, we're going back to chapter 1. We will figure this out together as far as how far do they want to take our answers. But you guys, that's the only variation this answer could have. Either you could leave it as x minus 4 squared, or you could FOIL that out and call it, you know, x squared minus 8x plus 16. Okay. So because we can't really practice this quotient rule business on anything harder, we'll go ahead and call it. I know it's a little bit early, but we learned the product, we learned the quotient. Again, I can't really give you any tough questions about it right now. They'll come, don't worry, you know. But here we are. I would just make sure you have them written down and written down correctly with the U's and V's in the correct places. Because that's another thing, guys. I mean, you're going to be doing your homework and taking tests at your house. You know, you can have a piece of paper with this written on it, you know, if you're worried about the memorization. With that being said, you do have to know how to use it, you know. So that's where your actual understanding of the thing is going to come in. But memorization, I guess, for us in this semester is really not an issue. Let's see. So yeah, I'll put that up. So remember, I do have this, I have a couple of classes after this, but I'm done at like 1, and that's when I'll go on and put more homework up. You still do have 11.5 in there anyway, and 4 and 5? I don't know, whatever. You have some homework in there already. So I'm trying to think of anything else important to say. I feel like there's something. Oh yeah. So guys, as we near the end of chapter 11, so this is 6. Friday we're going to do 11.7. We're almost at the end of chapter 11. So I want to go ahead and let you know that we always have a test after we're done with chapter 11. It's going to be a week from Friday. So I don't know what date that is, but it's a week from Friday. So wait, let's see. Today's the 2nd, 3rd, 4th. So it should be the 11th. Friday the 11th, we'll have our first test. The way the schedule is going to go until then. So like I said, this Friday, I'll do 11.7. And then we have Labor Day, right? So we're not even in school on Monday. During that time, so between times like Friday and Monday, I'll be putting up like a practice exam. So I can make a practice exam in MATLAB, and it can look a lot like your actual exam. And that's what I'm going to do. You guys, I'm going to put up a practice exam. It'll be, I'll probably put it in as a quiz score, which is great because when I do those, I let you work them as many times as you want until you get the right answer. So it's not so restrictive like an actual quiz. I just want to make sure you do it. So you're going to work on practice exam. It's going to be a quiz grade, but it should be an easy A on there. And then, so that's all happening while it's the weekend, it's Labor Day, you're working on that. And then on Wednesday, when we actually do come back, we'll have a class, but it's not going to be a learning things class. It's going to be if you have troubles with stuff on the practice exam, you get on and you talk to me about it. And if you don't, and if it all makes perfect sense, then I don't really need to see you on Wednesday. Not that I don't love to, just whatever you want to do, right? So it'll be kind of like a question and answer review day. And then on Friday, I will open the test. Now on Friday, we are going to learn something in class, but that's not going to be on the test. It's just Friday will be a normal class day, but the test will open that day also. I might even open it on Thursday if you guys feel like you need more time, because it'll be due on Sunday night, just like everything else. If you think Friday to Sunday is not enough time, let me know and I'll think about opening on Thursday. It doesn't really matter to me. That's the beauty of having these online classes, right? But anyway, you guys, that is open it on Thursday. I will. Done. All right, so that is the basic summary of, whatever happens up until the next test. And if you have any questions for me, then I am here to answer. And if you don't, then I will see you on, what's today? I will see you on Friday in class.